Our speaker today is Dr. Lucas Haag. So many of you know Lucas. He is our K-State Northwest Area Agronomist. He's also the interim agronomist in charge down at the Tribune Experiment Station. And so when he and I sat down and talked about the theme for Crop Talk today, I said, we'd really like to see kind of an overview of some of the research for crop rotations. That always tends to be a hot question, especially as we talk about intensifying rotations. And then we have lots of questions that come in about the role of tillage in some of these dry land crop rotations. And the reason for that is looking at getting a handle on some of these weeds that are a challenge to control with herbicides. And so what kind of a role does that fit in a crop rotation? And so we've got some work in Tribune and a couple other locations on that. And so I think with that, we'll turn this over to Lucas to share his screen and get started. I'm excited to hear his presentation today as we kind of go through thinking about kind of these questions we're thinking about dry land. And part of the reason for that is we've been in, a lot of kind of drought conditions for the last few years. While there's moisture on the ground in some locations in Northwest Kansas today, it's not all across here. And so, in the back of our minds, we're always thinking about managing moisture as we're going with this. So Lucas, are you there and able to get your screen shared?
How's that look?
Excellent. That looks great.
Okay, so yeah, I appreciate the opportunity to share some stuff with you guys today. And I was telling Jeannie earlier, if you happen to be at Cover Your Acres, a lot of these slides are going to look pretty familiar because it's a fairly similar talk to what we're presented up there. But again, trying to give an update on some of the latest from our long-term work at Tribune and bring in some economics, and hopefully get a little bit of time at the end. We'll touch real briefly on some alternative crops work as well. So anyways, am I showing? I got too many screens I'm looking at. Are you seeing the right one, Jeannie?
Yes, it looks good. We can see the screen. It says economics of dryland systems and rotations.
Okay.
With a aerial view of the Tribune station.
All right. So yeah, and I need to recognize maybe new Alan Schlegel retired in September of 21 after 36, 37 years of service at Tribune. And so a lot of these long-term studies and the data is really due to his work. And I've had the opportunity to keep things rolling there and try and use some of this data in other ways. So, all right. So yeah, Jeannie led into this, some of the things that we're going to try and cover. And so skip that slide. Always want to start with a little bit of a disclaimer here, especially when we get into the tillage part of this. I do appreciate how challenging weed management is today. And I know, we've had weed management as a topic earlier on in Crop Talk. And of course the weed schools that we held across the Northwest area. So again, I don't want to dismiss how challenging it is, but hopefully some of this data, some of this information can help you think through some of these decisions. Okay. You guys have likely maybe seen a photo similar to this before. This is from our long-term tillage trial at Tribune. Wheat sorghum fallow rotation started in 1991. Generally, most every year, it's pretty easy to visually pick apart the differences in these treatments. Some years are more apparent than others. Some years, maybe it's harder to tell the difference between the reduced till and the no-till. But in general, we can always see some differences there in this long-term tillage rotation. This is just an aerial view of it. So as I mentioned, it was native sod up until the late 80s. Would have been 89, 88, 89 when these plots were broke out. And Alan had the foresight, something that's really unique. There's other studies similar to this. There's a long-term rotation study at Akron, Colorado. But there's not a tillage part of that. There's a long-term tillage study at Sidney, Nebraska. That's in a wheat fallow rotation. We've got, and then some long-term wheat sorghum fallows with tillage treatments here at Tribune, and then down at Bushland, Texas, which is just west of Amarillo. One of the things Alan did here that was really had a lot of foresight, included in this design are native sod plots. They're actually part of the study. And so when we want to start looking at some things like soil carbon, water infiltration, soil health, we've got actually these native sod plots as part of the design that we can make comparisons against. So what actually is in the studies? I mentioned it's all in the context of wheat, sorghum, fallow rotation. We basically have 3 tillage systems in place. So in conventional till, we're using tillage as needed to control weeds. So, typically that's 4 or 5 times a year. Some both after wheat harvest and some after sorghum harvest or during that summer fallow period with sweet blade, essentially a full-blown conventional tillage type program. Then we've got reduced till. And what we're talking about in reduced till today is we're no till from wheat harvest through sorghum planting, but from sorghum harvest through wheat planting, in other words, through that longer summer fallow period, we are using some tillage for weed control there. And then no till, as the name implies, it's 100% no till. I mentioned the study started in 91. The data I'm presenting today is from 01 to present. And the reason we kind of got a bit of a line in the sand there is we changed the definition of reduced till in 2001. So from 91 through 2000, we were doing some tillage both prior to wheat planting and prior to sorghum planting. So we had some tillage going on both in that long fallow and that short fallow portions of the rotation. In 2001, we moved it to where all the tillage is happening during that longer summer fallow period between sorghum harvest and wheat planting. And in the reduced till, the sorghum is still being, quote, no-till planted into the wheat stubble. So no disturbance of the wheat stubble after harvest. Okay, here's our yields over years. So as you can see here on the across years average, really not that spectacular of wheat yields. We're averaging about 31 in the no-till, 25 in the reduced till, 22 in the conventional till. I always think it's interesting. We think about wheat as, Kansas, the wheat state, wheat being our stable, reliable crop. Actually, in our long-term studies at Tribune, and not just this one, but others, actually wheat tends to be more variable than sorghum when we think about yields across years. And so 2002 was drought. 2012 was drought, 13 was winter injury, 17 was wheat streak mosaic, 22 was hail, and 23 we failed to get decent stands. And so, this data is it includes it all, warts and all. But anyways, but we do see a significant difference in yields between the no-till, reduced till, and conventional till, although not, numerically not that, not that large. If we look at what's that difference look like as a function of yield environment, and so basically all this thing is what's the yield of the reduced till or the conventional till as a function of no-till wheat yield, all within the same year. So in general, as our yield potential goes up, as that yield environment goes up, the spread that we see between the reduced till, the conventional till, and the no-till gets wider. In lower yield environments, we don't see that large of a difference between the 3 tillage treatments. As we get to higher yielding environments, we see greater differences. Generally, what's more interesting, I think, out of this study is actually what we see in the sorghum yields. Now, the first thing I'll point out is if you look at the CV, which that's a measure of variability, where all the wheat yields were well above 100%, our sorghum yields, again, that CV, that variability is quite a bit lower, more stable across time. And so if you look at 2002 and 2012, which were exceptional drought years, other than that, we've had a harvestable crop every year in the study. And that actually goes back to 91. If we look at the full data set, 02 and 12 were the only years where we did not harvest something in those sorghum plots. So our long-term averages were running about 84 bushel on the no-till, 53 on the reduced till, 34 on the conventional till. So what I think is a really key point here I want to drive home is keep in mind, we talked about what these treatments mean. Keep in mind that both the no-till and the reduced till sorghum, both of those are no-till planted into undisturbed wheat stubble. And so if you think about what's really the difference here between reduced till and no-till, the difference between this 84 bushel sorghum and this 53 bushel sorghum, the difference is that we're doing tillage ahead of drilling wheat. Okay, and so that's been a pretty pronounced thing that's shown up in this data set is we are seeing a carryover effect. There is a legacy effect to doing tillage ahead of seeding wheat. And we don't see that big of a response in the wheat, but it shows up quite pronounced in the sorghum. And if you look through the years of data here, this isn't just a one-off thing. It's not a couple big years that are driving this long-term average. You can basically see through every year here where there is a significant advantage for the no-till over the reduced till. Now that it changes from year to year. We've got some years, you look at 2011 here, that's about a 35 bushel difference. We've got other years that are quite a bit narrower than that. You look at 2014, that was only about a 20 bushel difference. And we got a few years where there was no difference. You look at 2017, no difference between the reduced till and the no-till, but that was also a year we were harvesting some 160 bushel dryland sorghum. And so obviously we were not, I would suggest not water limited, in that type of scenario. So, but in general, we see a pretty big difference here between the no-till and the reduced till. And then the conventional till, that's just such a hit, both on the wheat and on the sorghum, that unless you're doing some type of organic production system and capturing an economic benefit there, it's really not worth talking about. Okay, similar to what I showed earlier on the wheat, this is just saying, okay, what's the yield of the reduced till or the conventional till versus the no-till sorghum? And again, like the wheat, as yield environment goes up, we tend to see those things spread apart. The exception to that would be that 2017 year when we was raising 160 bushel sorghum, and we really didn't see that difference between the no-till and the reduced till. But in general, at higher yield environments, we tend to see a little bit wider spread in that data. Okay, what's driving this big difference between the reduced till and the no-till? So this is profile water at wheat planting. If you look at on average, we've got about 8.5 inches of water in the no-till, sitting just a tick under 8 inches in the reduced till, and about 6.5, 6 3/4 inches in the conventional till. So we do see some differences. We tend to do a better job of storing that precipitation, higher fallow efficiencies in a no-till, followed by reduced till, and then conventional till being our lowest system in terms of fallow efficiency. What this looks like in terms of percentages, it's not uncommon for us to see fallow efficiencies for the no-till, pushing that 40% range, where our fallow efficiencies for the conventional till tend to be down in the 20%, 20-25% range. But what's probably more interesting is on the sorghum side of things. Again, essentially no statistical difference in profile water at sorghum planting between the no-till and the reduced till. But yet we're seeing this 30 bushel spread in yields. And so we can explain it with differences in profile water at planting. Now, the no-till and the reduced till both tend to average 2 inches more profile water than the conventional till. And so I think that really explains that drop off then further down to conventional till yields. But again, and this isn't unique to this study, and a lot of things in our long-term studies at Tribune, there's more happening than what we can explain by profile water at planting time. And so, the question is, well, what's driving this? I think to me, it has to be a pretty big in-season piece to this. We're making better use of the rain that we're receiving in season. And I think one thing, sorry, Jeannie.
I was going to ask you real quick, when on the available water in inches, how deep are we looking at for this profile water?
Yeah, so this would be in this particular study, we measure it down to 8 feet, an 8-foot profile. And we got some other studies, we only measure at 6 feet on the dry land, and we do see some water extraction down at those lower depths. It's not a lot, but in wheat and sorghum both, and our deep silt loam soils at Tribune, it's not uncommon for us to see some root water extraction down at the 6-foot mark.
Okay, great.
Yeah,
Thank you.
good question. So what do I think's driving this in-season piece of it? So this is actually some fairly old data now. This is once we were only 10 years into the study, looking at infiltration rates. And you've probably seen me show this slide before, but this would have been taken in July after wheat harvest. So we were measuring infiltration in growing sorghum about that tall, in fresh cut wheat stubble, and then in summer fallow. In general, what we've seen, regardless of what phase of the rotation we were in, if you look down here on the no-till, we were averaging about 1.20 inches in terms of ponded steady state infiltration. right at half of that in the reduced till. So he's getting 1.20 inch in the no-till, 60 hundredths in the reduced till, 45 hundredths in the conventional till. And so if we look at where we had growing sorghum, our infiltration was 93 hundredths in the no-till, 48 hundredths in the reduced till, 40 hundredths in the conventional till. And so if you look at these difference here in this infiltration rate between the no-till, reduced till, and conventional till in that growing sorghum crop, I think that goes a long ways in explaining what we're seeing in these yield differences, because it's not about profile water at planting in this case. It's about we're making better use of the rain that's coming down in season. One thing that I think is always interesting is, oftentimes native sod is held up as this, mimic nature, this holy grail. How do things compare to ground that we're not farming? I think it's interesting. Our infiltration on the native sod was about 96 hundredths, and so actually, on average, our infiltration into the native sod was less than what it was into our no-till cropland. And so I think that's kind of interesting, an interesting thing to look at.
Lucas, we do have a question that came in, and were the no-till plots kept no-till throughout the entire study, or were they rotated in the field? Just curious if there was more of an advantage to the longer the plot was in no-till.
Yeah, so these treatments are on the same plots through time. So what we say, these plots that we say are no-till, they in fact have been no-till since 1991. So and then what's reduced and the conventional till plots have been conventional till since 91. And then the reduced till plots, other than that little bit of a change in 01 in terms of what we were doing in reduced till, those are the same plots through time. Yep. So what we're calling no-till, those are, approaching 34 years now of continuous no-till. Yep, great. Good question. Okay, what drives infiltration? Let's see, there we go. Won't spend a lot of time on this, but in general, aggregate stability. Having that long-term no-till gives us a higher percentage of our soil aggregates or larger, which improves our infiltration rate, and we won't go into a lot more depth on that, but that's what's driving that piece of it. Okay, so we've put some economics to this, and so a little bit of my assumptions here on cost. We're using K-State custom rates on the machinery cost side of things. I am including the cost of the preceding fallow period with the cost of that crop. So in other words, the cost of summer fallow is getting attached to the wheat crop, and then the cost of keeping the wheat stubble clean from wheat harvest up through sorghum planting, that's getting attached to the sorghum crop. And so basically, we started looking at this a number of years ago when we had, really that large run up in herbicide prices. At the same time, we had a really strong wave of weed resistance issues. And so we were getting that question of, okay, the economics of this, do the higher yields pay for the higher chemical cost in this, by sticking with a no-till type system? So that's really what drove us to start looking at this. Okay, here's the cost I'm plugging in, and what I do in December, typically prior to Cover Your Acres. I send a survey out to a half dozen or so retailers or wholesalers in the region. I say, okay, give me your average, not the best deal you're shooting the guy, but not full retail either. Give me kind of the weighted average of what you think product will be going out the door this year. So these are cash and carry prices. We're assuming you're running them through your own rig. And we're using generics where possible. And so these are the types of numbers. This is the average of those survey responses that I got back. And then these are the machinery costs out of K-State Ag Manager custom rates that I'm using. And on the machinery costs, there's a value reported for Northwest, West Central, and Southwest. Some of those are pretty thin. There's not very many numbers going into the average. And so what I've opted to do, this is the average of the 3 Western reporting districts. So this is the average of Northwest, West Central, and Southwest is what I'm using in our economics here. This is outdated, but the economics was based on what we could sell new crop for. And even if I would have done it last night, obviously it would be outdated this morning based on our market moves today. But this on the 20th of January, this is what we could book new crop for at CHS Tribune. So that's what I'm using on the revenue side. On the first piece of this, on the tillage study, I'm not including any crop insurance or government payments because really we're just looking at the tillage piece of this. Later on, we'll bring some of this back in when we're talking rotations. Okay, fertilizer use, I'm assuming now what we do in the plots is, we're using basically liquid for all of our in-source. And then on FOSS, we're doing 1034.0 with the planter or 1152.0 in furrow with the drill. However, for the economics, I'm assuming if you're doing this at the farm scale, okay, these are the assumptions I'm using. And that is that if you're using conventional till or reduced till, you're dragging a sweep. And so you're probably going to be using anhide just because you're making that pass anyways. It's the cheapest form of N available. And so on the budgets for conventional till and reduced till, I'm using anhide as our wheat nitrogen source. And then I'm using UAN for the no-till systems, and then also for that reduced till sorghum. I'm using our K-State NREC based on average yield for the N rates. On the FOSS, I'm using crop removal to maintain a solid, a level soil test P. And then we're using 1152.0 in furrow with the wheat, assuming you're putting it on through air seeder, drill, or whatever, and then 1034.0 with the planter for sorghum. Okay, so back to this question of how much can I afford to spend on no-till fallow? And what we're looking at here, the numbers in this grid, this is the difference in net returns between reduced till and no-till. And what that difference in net returns would be at varying levels of wheat price as you move across the top, or varying levels of sorghum price as you move down through the rows. And so the thing you'll notice here, we can go from $4 wheat to $8 wheat, and that only changes our allowable fallow cost by 22 bucks an acre. But if we go from $3.50 sorghum to $7 sorghum, now we're changing allowable fallow cost by $107 an acre. But if you go back to think about what we were seeing in differences in yields, yeah, we saw some differences in wheat, but numerically it wasn't that large. We're talking 5 bushel difference in revenue, okay? But on the sorghum side, we was talking over 30 bushel difference, 30 bushel in revenue. And so when you think about that, not surprisingly, the sorghum revenue is what's really driving the bus here. And so not surprising that we're most sensitive to changes in sorghum price when we think about this difference in net returns between either a reduced till or a no-till system. Okay, so January of 2023, that's when we had a really spike in herbicide prices, if you remember. So that's really got us to thinking about this. And so anywhere in red is where reduced till would have an economic advantage in net returns. Anything in white is where no-till would have an economic advantage in net returns. And so you can kind of see there, 450 sorghum, basically we had to keep our allowable fallow cost under 160 bucks an acre. That includes product and application in order for no-till to be the profitable option. You get down to $4, 375 sorghum. Well, now we are back to only having about $135 in allowable fallow costs in order for no-till to remain the more profitable option. Okay, January 2024. So a little over a year ago, what happened? Well, actually, we were dealing with a little bit stronger commodity prices, and we had seen those herbicide prices ease off quite a bit. And so that really shifted the economics, really reduced that area of scenarios where reduced till had an economic advantage. And that's really kind of where we were this past January as well. So this is with those new crop prices I shown, as well as those survey prices. And really, we've got a fairly small quadrant here where, at least based on our data, our long-term trial data at Tribune, a fairly small set of scenarios to where reduced till would actually have an economic advantage. Okay, now, but what if you don't believe my yields? Okay, so for data from the last 23, I needed to update that, should actually say 24 years. Our long-term study shows that reduced till sorghum makes about 64% of no-till. So 82 versus 52, a 30 bushel spread there. Well, maybe that sounds too good to be true. And what if the difference isn't that big on your farm? How sensitive are these economics to that yield differential between the no-till and the reduced till sorghum? So this is, again, using our current year assumptions and looking at how does that change, how sensitive we are to that yield differential. So the clear bottom line here, this is saying, okay, I 100% believe the data this guy from Tribune showing me. This is what those differences in net returns would look like. Okay, but if we move, not untypical for us to believe that we move from west to east across the state, that the benefit to no-till declines. Okay. And so you say, well, maybe on my farm, I don't believe the difference is that big. Maybe I think it's only half as big, 15 bushel difference. So 84 bushel no-till, 69 bushel reduced till. Well, you can see there now we're talking about that breakover point somewhere around that $135 an acre would be our allowable fallow cost to stay in no-till versus going to a reduced till type scenario. So, cutting that back quite a bit. What if you say, well, a Haag guy, he's only 20% right. I think it's only 84 bushel versus 78 bushel. Well, now we're down to only about $105 an acre allowable fallow cost. So we are, because again, the revenue, the sorghum revenue, the difference in sorghum revenue between the no-till and the reduced till is what's really driving the economics here. So if you don't believe you're getting that yield response from a long-term no-till scenario, then that is what's really driving it. Okay, I saw the question come in: is the no-till fallow cost what you can spend on top of conventional fallow? No, so the way we're looking at this is an either or, and so I've already got on the reduced till economics, I've already got the cost of pulling the sweeps, on average 4 times built in there, and so basically this number here is what you can afford to spend on herbicide and application. So we've already we've got to do one or the other. And so what we're looking at here is what you can afford to spend on herbicide and application and still be money ahead. Good question. Oops. Okay, there we go. So again, not intended to dismiss the challenges of weed control today, but I think this data suggests it's worth thinking about, and it's easy to dismiss. It's easy to say, well, I don't see, when we do some tillage ahead of the wheat, our wheat's no worse and maybe even sometimes better. No-till wheat can be a challenge. And so, but I think our data suggests that, hey, there's some bigger picture things. There are some legacy effects to doing tillage ahead of wheat that is impacting our sorghum yields. And so thinking through the whole picture here, when I make that decision to pull the sweeps, it's not just about the wheat crop, but what's it doing to the entire system. Okay, now we've got some challenges out there, especially with our summer annual grasses, tumble windmill grass, 3-on, those types of things. So what about strategic tillage or occasional tillage? How does that fit into the picture here? So we'll visit about that briefly. Okay, first I want to talk about strategic tillage. And so this is some work Augustine Abor did over at Hayes. And by strategic tillage, we're talking about a one-time tillage of what would otherwise be no-till ground. And so these were no-till plots established in 1976. They've got a rotation component to it. So wheat fallow, wheat sorghum fallow, continuous wheat, continuous sorghum, and then a sorghum fallow. But then what Augustine did was in July of 2016, split those long-term no-till plots and then did a one-time strategic tillage using a sweep blade with the goal of controlling grassy weeds, particular 3-on and tumble windmill grass. And then they've revisited that and done some measurements of those plots over the years since then. So again, the plots were swept in 2016. They came back in 2022 and measured soil organic carbon. And what you can see is here in the surface at the 2-inch depth, we are picking up a bit of a difference. So the blue represents no-till. The red is where a one-time tillage application was done. And then the green is where we had been in a reduced till system. So in other words, tillage happening basically every year during that fallow period. And we do see a bit of a separation here in soil organic carbon at that 2-inch measurement depth. Now, by the time we're down here to 6 inches and 12 inches, there's really no statistical differences between those there. The other thing Augustine wanted to look at was what about soil pH? That is one of the things we're observing in our long-term no-till is that we get that stratification, surface or near surface application of nitrogen over the years. As we convert that nitrogen out of urea form, that causes a decrease in acidification, a decrease in soil pH. And so would tillage affect that? This is just looking at the rotation piece of it. So continuous wheat, we've got the lowest pHs in there. A lot of that comes back to how that nitrogen was getting applied in that continuous wheat system. and a lot of, basically all of that being surface type application. Probably what's more interesting there is the tillage piece of it. So again, here's the no-tills in the blue line, followed by strategic till and reduced till. And so, but if you think about what we're doing with a sweep blade, it's not really a mixing operation. For all the reasons we like sweep tillage, we're keeping the residue on the surface, minimal disturbance, but there's not a lot of mixing going on. So not surprisingly, we moved the needle a little bit. Here's the reduced till, we're doing tillage every year during the fallow period, averaging around that 5.5 pH at the 2-inch depth. Statistically no different between the no-till and the strategic tillage. Numerically, maybe moved it just a little bit there. But if we think stratification is an issue, using a sweep plow is probably not going to get us enough mixing to really affect that. But I think we got to go back to the question of really how concerned are we on this pH issue, and there's a lot of questions that need to be answered there yet. What about yields after this one-time tillage? So this is winter wheat yield. Basically, no difference due to the strategic tillage. It's coming in basically the same as no-till. The exception to that is in the continuous wheat treatment. What's driving this here is the control of, basically you think back to our brome species. There's some other management things that they've not been using a clear field or a coaxium wheat in this system, so they are picking up a tillage effect here. There's some other things we could be doing maybe to get this effect. But if we look in the wheat sorghum fallow rotation here, really no difference in the wheat yields between the no-till and the strategic till. Are picking up a little bit of a bump in wheat yields in that reduced till treatment. But again, some years reduced till wheat is competitive, depending upon the scenario we're putting that wheat into. Wheat is our most challenging crop to get to perform in a continuous no-till system. Okay, so here's the sorghum yields over time since that one-year tillage event in 2016. Again, no difference between the no-till and the strategic tillage, the black and the blue bars here. But we are picking up, a yield difference. In general, the no-till and the one-time tillage performing better than sorghum produced in a reduced till type system. Okay, so that's a strategic tillage. That was a one-time application of one-time tillage of otherwise no-till type ground. What about occasional till? And so here's a study, and we've got this going on at Tribune, at Garden, and at Hayes, where we're looking at no-till, tilling once during the summer fallow period, tilling once after wheat harvest, tilling once in the summer fallow period and once after wheat harvest, and then tilling twice in the summer fallow period. 3 of these treatments, we've got data going back to 2014 for, and then we revised the trial in 2019 and added these other 2 treatments. And in general, this is on average at Tribune, we're not seeing any difference in wheat yields between the no-till, tilling once during fallow, or once after harvest, or any of these other combinations. Essentially no statistical difference in wheat yields at Tribune, either from 2014 to present or 2019 to present with these treatments. Now in the sorghum, we are starting to see a bit of a difference here. So if we look at these 3 treatments that we've got the longest set of data on, we're averaging basically 112 for the no-till sorghum, 105 if we till it once during the summer fallow period, and then 102, 103 if we till it once after wheat harvest, so disturbing that wheat stubble. To be honest, I'm surprised this tilling the wheat stubble isn't affecting us more. Because if you go back to thinking through, that in-season effect, more residue, more infiltration. But I think if we went back through and looked at some of the individual wheat years, I think that's something we need to dig into is, okay, if you're starting with 70, 80 bushel wheat stubble, that one-time tillage of the wheat stubble is probably not going to hurt you as bad, or maybe not at all, as opposed to if you're only starting with some 20 bushel wheat stubble. So I think there's some things in the year-by-year data here that we can look at a little bit more. With these, the full set of treatments here from 2019 till present, We're 102 bushel on the no-till sorghum, 93 if we till it once during summer fallow, 92 if we till it after wheat harvest. If we till it once in fallow and July after wheat harvest, that's given us our lowest yield coming in at 83. And then if we till it twice during summer fallow, also coming in at about 93. Now, important to point out, at Garden and at Hayes, they have not seen this same response in sorghum yield that we are seeing at Tribune. So I don't know. I think it's going to be interesting to play out. We hope to keep this study going. This is really the value in long-term research. The first few years of this study, if we would have stopped it after 3 years in, we would have walked away and said, nah, it doesn't make any difference. You can till it once during fallow or once after we harvest and doesn't matter. But again, we're seeing a cumulative longer-term effect here. And again, you go back to, it took time for the benefits to no-till to show up. Not surprising to think that, these are fairly resilient systems. Not far-fetched to think that it wouldn't also take time for things to go the other direction as well. Okay, we're going to shift gears a little bit here to some rotation work that we've looked at. And this is a picture of our large-scale long-term rotation plots. This is looking east-southeast back towards Tribune and the main station. We've talked a little bit, and this comes back into how we think about things from an economic standpoint. And one of the things that I think is a little bit different way of thinking about things is how do we partition out our land costs, our land charge, okay? And I would make the argument, one of the ways we can think about that is, how valuable is dryland farm ground if it doesn't rain? And I would argue what we're really renting is access to precipitation, okay? And so if we partition our land charge or our cash rent out based on when the crops in the rotation are actually using or have access to that water, maybe that's a little more fair way to think about our budgets. And so that's kind of what I'm doing as an example here. Here's wheat sorghum fallow versus wheat sorghum fallow. If we partition it that way, in a wheat sorghum fallow, the wheat's having to carry, in this example, about $83 of the land charge. The sorghum's carrying $67. If we do wheat sorghum fallow, again, the wheat's still having to carry 83. That first crop sorghum's carrying 67, but this second crop sorghum only has to carry 50. And you say, well, that second crop sorghum is not going to make as much revenue. It's not going to yield as well, and that's right. But it doesn't have to, because we're going to have a lower cost involved. We got lower land charge involved. We're using less of the water during that whole period of time we're renting the ground. We don't have all the herbicide cost of keeping that wheat stubble clean. Basically, all we got to do is, if we're going from sorghum harvest to the next sorghum planting, we don't have that period of keeping stubble clean. So it is a cheaper sorghum crop to grow. That's same data, just same numbers, just a different way of looking at it. So this is one of the things we've looked at. This is a study Alan started in 96. So that next step of intensification of what if we go to 3 crops in 4 years or a continuous system, what's that look like? So we have wheat, sorghum fallow, wheat, sorghum fallow, continuous wheat, and this is all done in a no-till type scenario. Okay, these are average yields across these years. And so here we're averaging basically 40 some bushel wheat, as long as that wheat's after fallow. Second crop wheat averaging about 30 bushel, and then continuous wheat coming in at 25. And then on the sorghum yields, it doesn't matter if that sorghum's after 1 year of wheat or 2 years of wheat, still basically coming in a tick under 90, but then our recrop sorghum coming in at 60. So basically 2/3. And that's kind of a reoccurring theme that you'll see is anytime we're recropping row crop, we're making about 2/3 of what that crop would make planted into wheat stubble in that same year. Now, I say it doesn't matter if sorghum follows 1 year of wheat or 2. There are a few exceptions to that we've seen over the years. And so these are 3 years in the study where it mattered whether that sorghum was after 1 year of wheat or 2 years of wheat. And if you look at what's really driving this, here's the sequence. So this is the prior year wheat crop, sorghum into first year wheat, or for sorghum that was after 2 years wheat, this is after the first and the second wheat crop. And so for those years where we've got an advantage to sorghum following 2 years of wheat, it's really, really driven by when we have some poor wheat yields in here. So we've got, after a 35 and a 27, so nothing really spectacular here. Here's after a 6 and a 41, or after a 77 and a 4. And so in other words, making that decision of, hey, when I've had a really poor wheat crop, being able to recrop a second year of wheat in there, build up my levels of stubble before I go to sorghum. I think this is an idea we're going to investigate a little more, is what is that threshold? How much stubble do I need out there to be confident in making that step to go into row crop, versus should I grow another year of wheat in order to grow some more stubble? So we're going to build on this a bit. We've got some plots out this year. We've got wheat. We're going to try and thin down to different densities of stubble, go back and plant either corn or sorghum back into that, and see if we can kind of nail this down a little bit more. Okay, so this is looking at recrop sorghum yields by year. And so what we're looking at is on the vertical axis, this is what did sorghum into sorghum stalks make versus sorghum into wheat stubble, okay? And so we got, there's obviously a relationship there. We've got some scatter in the data. But again, on average, that recrop sorghum's making about 2/3 of what first crop did. But we certainly had some outliers in there. If you look at 2014, we were cutting 85 bushel sorghum into wheat stubble, and 7 bushel recrop sorghum. Well, what happened here is that recrop sorghum went under stress. What's sorghum do when it goes under stress? It shuts down and waits. And when you're trying to grow sorghum at 3,600 feet elevation at Tribune, you can wait too long. And so our recrop sorghum essentially got froze, and we were cutting 7 bushel fluff, while our sorghum into wheat stubble was making 85, 90. And so we've got those one-off deals like that. And we've got some other years where actually the recrop did as well as a sorghum into wheat stubble. So 2013 is a good example of that. Our recrop's basically making almost 100. Our sorghum into wheat stubble was just a tick over 100. So pretty much on par with each other. So I want to see, okay, what can we learn from this? What's another way of looking at this data? And I think this is really interesting. I'd argue still probably one of the more interesting graphs I've ever created the first time I looked at this. And this is relative yield of recrop sorghum to the first crop versus how much water did we have in the profile planting. So in other words, a value of 0.7 means that sorghum into sorghum stalks made 70% of what sorghum into wheat stubble did. And so on the left-hand side here, 4 inches in the profile planting, that's pretty much a dry profile. As we get over here to the right side, 11 inches, that's basically a full profile. This is measured in this study, we're measuring to 6 feet. So if you look at, not surprisingly, on average, so the wetter the profile we start with, the better our recrop does versus into wheat stubble. But what I think is more interesting in here is how much spread do we have in this when we're starting with a dry profile? Well, we're pretty reliant on in-season precip, so we've got this really large spread in potential outcomes. Now, as we're moving towards a wetter and wetter and wetter profile, to the time you're over here on the right-hand side, starting with a full profile, we have really narrowed the spread in that data. We have a lot more confidence in what that recrop sorghum could make. And so I think that's a really interesting thing to think about here, is as the profile fills up with water, not only does our yield potential goes up, but our variability and potential outcomes shrinks. Now, that's not really rocket science. Those are things all inherently we would believe, but I think it's really cool that the data bears that out, and we can actually start to put some numbers on this. And one way we can do that, if you look at this green box up here, okay, if we think back to just the budgets of what's it take to grow recrop sorghum versus sorghum into wheat stubble, our costs on recrop sorghum are about 62% of what they are for sorghum into wheat stubble. So another way of thinking about this is if we can be sure that our relative yields are above 62%, or somewhere up in this green box above a relative yield of 0.62, that means our recrop sorghum economically will be at least as good as our sorghum into wheat stubble. Now, that's no guarantee you're going to make money on either one of them. It just means that it's going to put that recrop on economic footing that's at least as good as our sorghum planted into wheat stubble is. And so, again, thinking through that, well, what's it take to get us in this green box? Well, it really means we need profile water to be somewhere above about 6 1/4, 6.5 inches of water in the profile is what's going to put us up into that green box of having the best chance of economic returns. Well, how do we get at that number? Well, we can do a ball rod measurement. The other thing we can do, and this actually works pretty good, at least based on our data at Tribune, we can look at how much precip have we had since we harvested sorghum last fall. And basically, and keep in mind, our fallow efficiency over the winter is pretty high. We hold on to the vast majority of the precip we receive during the winter. And so in order to get 6 inches of profile water at planting time, 6.5 inches, I need about 6.5 inches of precip from the harvest of the prior sorghum crop. If I'm above that, that's a pretty good sign that I'm moving into an area that I've got good potential for economic returns there on recrop sorghum. Let's see here. We're going to skip that slide. Oops, got too many slides going here. Okay, so that's kind of the take home on the recrop. I'm going to hit on a few other things. We also got wheat, corn, sorghum fallow, wheat, sorghum, corn fallow, wheat, sorghum fallow, wheat, corn fallow in this large scale long-term study that started in 1993. We'll look at those yields here right quick. In general, we don't see that big of a difference in our wheat yields. Our highest wheat yields come out of the wheat, sorghum, fallow rotation, followed by wheat, sorghum, corn, fallow. Our lowest yields are actually out of wheat, corn, sorghum, fallow. Here's our wheat fallow. This is actually the only treatment that's reduced till. Everything else is full no-till, but we've got this long-term reduced till wheat fallow check. Despite having that very long fallow period and the ability to store water, really those wheat yields don't come off any better than our wheat yields that are in rotation with any series of row crops. Our sorghum yields, again, didn't matter if the sorghum is wheat, sorghum, fallow or wheat, sorghum, corn, fallow. Sorghum yields averaging 85. Adding that corn crop in there doesn't hurt our sorghum yields. When we look at either sorghum after corn or continuous sorghum, both of those coming in at 56 bushel. Corn, kind of a similar story. As long as that corn's planted into wheat stubble, coming in at just a tick under 60 bushel. Doesn't matter if we follow it up with another sorghum crop. And then corn back into sorghum stalks coming in at 40. So again, this trend shows up again anytime we're recropping row crop, coming in at about 2/3 of what that crop makes planted into wheat stubble. Corn, very similar to sorghum. Again, about does a little slightly higher, about 68% of the first crop. This is looking at recrop corn, so corn into sorghum stalks versus corn into wheat stubble in this case. We're not as tightly related to profile water at planting time. With sorghum, that was a really nice relationship. Corn, you think about that, we are a lot more reliant on getting some well-timed in-season precip. So we can't do quite as good a job as predicting recrop corn yields based on how much water we got in the profile and planting. Certainly more is better. As we start with a wetter profile, our potential goes up, but just a lot of noise in that data. Okay, I'm going to skip ahead a few slides in the interest of time. This is just economic return for second crop sorghum. At current prices, basically, if you think you can raise somewhere between 90 and 95 bushel sorghum into wheat stubble, we think that would, if you're above that mark at 4 1/4 sorghum, that puts us into positive net returns for recrop sorghum. So that's just kind of where those crossover points are in there. Let's see. I think we've hit on this enough. We've talked about this, but the take home is preliminary work suggests as long as we get 6.5 inches of fallow precip since the prior sorghum harvest, that's going to put us into that green box where recrop sorghum economically stands a chance to be at least as good as our sorghum into wheat stubble. Okay. We've talked these rotations a little bit already. Think about how to use my last few minutes here. But these are the current rotations we've got in our large scale long-term study. I'll talk here a little bit here at the end. This wheat, sorghum, cowpea is kind of a new thing that we're looking at. Here's our wheat yields over time. Let me get to, here's our sorghum yields over time. Again, kind of these same things show through. Recrop making about 2/3, and on the corn yields. Now, here's the thing. I get questions. Let's go to the summary slide here. This is more useful. I get questions, this is why we looked at this wheat, corn, sorghum, fallow, wheat, sorghum, corn, fallow. There's really no magic to one sequence versus the other. I would tell you at Tribune, I'm pretty gun shy of this wheat, sorghum, corn, fallow, just because we can fail that corn crop or have a pretty poor crop with not very much residue. And if that corn crop's not in good shape, and then you're going to that summer fallow period, that's an awfully long time to go with pretty poor residue on the surface. I like the wheat, corn, sorghum, fallow better from a 4-year rotation, or wheat, sorghum, sorghum, fallow, simply because that puts us in so much of a better sorghum surface residue standpoint going into the fallow period. Real briefly on some economics here. Let me move ahead. That was last year without crop insurance. And so this year we've put some crop insurance back into it. We already talked about our assumed prices here. The initial wheat price has already been set at $5.90. I should have re-upped this. We've set the corn and sorghum price here at the end of February, but this is what I used at the time we did the analysis. And so this is with current prices, average net returns to these rotations with insurance. What's interesting is the continuous sorghum looks to be the most profitable, and these are full costs. Again, this is full custom rates, so full depreciation, full labor, everything is bid into the cost here, full land charges. So this is everything. Okay, continuous sorghum being the highest net returns, followed by wheat, sorghum, fallow, wheat, sorghum, corn, fallow. Of course, wheat fallow being our least profitable. That's not particularly surprising there. On the insurance, I'm assuming a 80% enterprise units is what we're using to figure our insurance on this, both on the premium side as well as the indemnity side as well. Okay, so how much is insurance adding to this? So this is at current prices with and without insurance. So basically, if you look here on the continuous sorghum, the value of crop insurance, it's basically bringing $30 an acre to the table. If you look at that difference in average net returns between the two. If you look over here on the wheat, sorghum, fallow, basically crop insurance is bringing $15 to the table in terms of average net returns. So a pretty important driver here in terms of net revenue. With and without land charge. Well, you should always pay a land charge even on your budgets, even if you own the land. But for some weird reason, let's say land is free. How much does that change things? Well, all of a sudden we go from seeing a lot of red to a lot of black. And so the take-home message here is, where are you at on lease agreements? Do we have equitable arrangements with our landlords for the current profitability situation? Because land charge is a fairly significant driver in profitability. Now, what if things aren't good right now in terms of revenue as well as cost? What if we took the average of the last 3 years for average prices? So what if we plug in $5.55 for corn, $5.48 sorghum, $7.06 wheat, and then also use the average insurance guarantees for that 3-year time period as well? Well, now we can start to see some net profitability come back into this. Interestingly, continuous sorghum in our data continues to come in at a fairly high number, but then we've got wheat, sorghum, fallow, wheat, sorghum, corn, fallow being very competitive, and then wheat, corn, sorghum, fallow coming in after that. The wheat, corn, fallow, we've got some insurance claims in here, but we never have enough good corn years to raise our APH to the point where we collect better in those hit years. And so the profitability of the wheat, corn, fallow, even with the crop insurance in there, just doesn't quite get there. Okay, now this is an important thing just to talk about. This is using the yield adjustment and the yield enhancement averages. And we're coming up on March 15th, which is the closing date for spring crops. It pays to understand what are the different APH options you have available. So these are our wheat yields using just a straight mean. This is a straight average of what we actually harvested. This is using yield adjustment. So basically, you essentially put a floor in there using the 60% of county T. And then this is using yield adjustment and yield enhancement. So keep in mind, yield enhancement, that's determined on a county by county basis for each crop for each year. If the county average for that year is less than 50% of the long-term average, you can throw it out. You can choose to throw your yield record out. And so that can make a pretty big difference on some of these, specifically on sorghum. We'll point that out. So this is our records on the continuous sorghum treatment. So SS, this is what we actually harvested. These are the yields. The years that are in gray, those are the years where Greeley County was eligible for yield exclusion. Okay, you as a producer have the option of kicking that year out of your history if you choose. Now, note you don't have to. Okay, and that's a really important thing to know. On our corn history, especially, there were some years where I could have chosen yield exclusion, but actually my yield was higher than what the county average, the number plugging back in there, would have been. So I was better off to keep my yield and not use the yield exclusion. In sorghum, however, we were better off to take yield exclusion in all these years. So, you know, our true average in this treatment has been 55.6 bushel. Adjusted yield, basically using that 60% of T as a floor, gives us an APH of 58. And if I use yield exclusion, that gives me an APH of 70. So basically, I can insure 70 bushel sorghum, even though my long-term average is really 55 in this particular example. And so that's part of what's driving those higher net returns for that continuous sorghum treatment. Now, what's really driving that is the fact that in 2016 and 2017, we had two spectacular years where we had continuous sorghum making 113 and 135 bushel. And so that really boosted our APH. And then the ability to throw out some bad years with yield exclusion gives me this 70 bushel APH that I can insure. So how much does that change things, those two high yielding years? If I don't have those two high yielding years, it basically wipes out about $23 of that average net returns for that continuous sorghum treatment, and basically would put it right back on footing, equal footing with the wheat sorghum fallow and the wheat sorghum corn fallow. So it almost gets to where if you start thinking about rotation options, you almost have to think about on a field by field basis, what do my APHs look like? Because without those two really high yield years in there, all of a sudden continuous sorghum's not any better than several of these other options that we have. So anyways, it's worth some time to go through really at the field level, go through those APH records. Don't just blindly take yield exclusion on everything, but realize it can be a pretty valuable tool. Real briefly, alternative crops and things we're getting lots of questions on. You know, we've done work in the past with spring field pea. We may revisit that. Winter field pea continues to be something we work on. We've done some work with millet. Camelina, we've got some work on that in Kansas. Augustina Borat Hayes is really our camelina expert. But the thing I'll visit real briefly about is cowpeas. These are a warm season legume native to Africa. All black-eyed peas are cowpeas, but not all cowpeas are black-eyed peas. And so really the most common market class that we're thinking about are these black-eyed peas, but there are other market classes out there on the market. Pretty heat and drought tolerant crop. Jeannie and I have been working with these the last few years, and I would tell you we've both been pretty blown away by how well we've put these things into some pretty tough situations, and they've have always surprised us by what they've been able to come up with for yield. A pretty short duration crop, and we've planted these fairly late and still made a crop. Sometimes we joke about doing research, kind of interesting, but yet disheartening. I come across this photo in the archives. Actually, in 1925, we were growing cowpeas at the Tribune Station. Of course, this is more from a forage standpoint, but that definitely was not a no-till system. You look at that. But anyways, we've chosen to put these in one of our dryland rotations. We had an extra wheat sorghum fallow slot, so we've moved that to looking at wheat sorghum cowpea. And so we only got 2 years of data there. In 23, they averaged about 1,000 pounds. This last year, we averaged 1,200 pounds. And then we're putting those plots right back to wheat. Those cowpeas are using water. Oops, that's the wrong axis. This is actually profile water at wheat planting time. So right after the cowpeas, we only got about 3 3/4 inches of water in the profile, where basically everything else after fallow is somewhere between 6 3/4 and 7 1/2. Of course, wheat fallow is a little bit higher there. Where are they using the water? Most of that water use is in the second, third, and fourth foot of the profile is really where those cowpeas are using the water. This is profile water at wheat planting. Here's all the fallow treatments, pretty similar, but you can see the cowpeas in the blue bar are using some water. Not surprisingly, if you're going to grow something, it's using water. We only got 1 year of wheat yields, looking to see how did planting cowpea affect our subsequent wheat crop. We took a pretty hard hit in wheat after cowpea this year, 20 bushel wheat after cowpea. Wheat after our other rotation options, averaging anywhere between 50 and 62. I would say, our wheat was looking really tough this past spring, until we got some rain just in the nick of the time. And that wheat after cowpea had stressed to the point where even when we got that precip later on, it really wasn't recoverable. We had done enough damage to the yield potential of that crop. It wasn't able to take advantage of those rains we got. Had we not got that rain, I think we would have been looking at 20 bushel wheat across the board here. Yields on cowpeas, they don't respond all that much to irrigation, and some colleagues over at Akron have been doing some work. Really, 3, 4, 5 inches of irrigation water are enough to really maximize the benefit of irrigating cowpeas. Again, just 1 year data here at Colby, where we had both an irrigated and a dryland variety trial. Done some very limited seeding rate work, but we're kind of thinking dryland around those 75,000 seed per acre, and then on irrigated somewhere around 120,000 seed per acre. We've also done some work looking at nitrogen inoculant, really too early to tell much on that. We've done some work looking at different genetics and hoping to expand that as well. Okay, I went 5 minutes over time, but hopefully, but we've taken some questions as we went. And so hopefully that's been helpful, and I will figure out how to stop sharing slides, maybe. And yeah, appreciate you guys' time this afternoon, and happy to answer any questions or comments. I don't think I've seen any more come in on the chat.
If you've got questions, put them in the Q&A box, put them in the chat box, and Stacy, there you go.
Okay. Yeah, if there's any questions, now would be the time to, like Jeannie said, throw them in the Q&A or the chat box. Okay, well, it seems like there's not any more questions, but if you do have one, feel free to type it in while we're finishing up here. Basically, I'm Stacy Campbell, and the evaluation, we ask you to please fill that out. That helps us, like Lacey said, kind of try to see where we need to be on trying to help you guys out. So there's the link for that. And Jeannie's probably also going to put that link in the chat if she hasn't already for the evaluation, but please take just a few minutes to do that. We really, really appreciate it. And then certified crop advisors, be sure and email Jeannie Falk Jones again. You can do that now to get your CCA credits for that.
Hey, Stacy, I had one question come in, if I could take a minute to answer it.
Okay, sure.
Yeah, so I got some questions on planting dates on cowpeas and how all that's fitting together. I would tell you our cowpea planting has been later than we would like. Part of that's been getting seed has been a real challenge. The first year we dabbled with these, we actually planted them on July 4th. Jeannie and I was out riding a planter. And they still, we put them in I was up here at Colby. The wheat was not great. We were bone dry. These were essentially double crop cowpeas. As dry land, the wheat had been cut. We planted them on the 4th of July. We had one decent rain during fair week of like 1.40 inches, and those things still made 400 pounds, and they shouldn't have made anything. And now we've been doing better since that, typically getting them in sometime in mid-June. They could go in really that first week of June, pretty similar. You think about planting, good conditions for planting sorghum, very similar conditions for planting cowpeas. And that's one thing I'm trying to do is get our cowpea, like on the rotation study, get our cowpea planting date moved up with the idea that hopefully we could get them off a little bit earlier and maybe open up about a 3-week window, a chance to catch some moisture before we drill wheat. We've not been getting our cowpeas planted at Tribune until June 15, June 20. And so for the last 2 years there, the cowpeas have come off and literally we're drilling wheat the next day. And so it's been a very tight rotation. I think we could manage our planting dates on the cowpea side to open that up just a little bit more. But in general, pretty similar. You know, if it's good conditions to plant sorghum, it's a good time to plant cowpeas.